January 2013. So this one is the first problem. So let me make this one bigger. Okay, can you read this problem?
Okay. Farmer John's cows have been causing too much trouble around the farm, and Farmer John therefore wants to keep a more watchful eye on them. By installing end reflective fences at various locations on the farm, he hopes to be able to see from his house at location 0 to the barn at location AB. On a 2D map of Farmer John's farm, fence I appears as a short line segment centered at integer location xi to yi tilted 45 degrees. For example, a fence oriented like at position 3,5 could be described as a line segment from 2.9 for 4.9 to 3.1 to 5.1. Each fence lies at a different position within integer coordinates in the range negative 1 million to 1 million. No fence lies at 0, 0, or AB. Farmer John plans to sit at his house at position 0, 0 and look directly to the right in the positive x direction. With his gaze bouncing off some of the reflective fences on his farm, he hopes to be able to see the point AB. Unfortunately, Farmer John thinks he's oriented one of his fences incorrectly. Please output the index of the first fence in Farmer John's list such that by toggling its direction, Farmer John will be able to see the point AB.
Okay. So this problem, the input file format is this. First line, they give you 3 integers, n, a, and b. So for this example, n equals 5. So that means they have 5 fences or 5 mirrors in this field. Then a and b, that's the coordinate, x coordinate and y coordinate of the bar. Then start from the second line to n plus 1 line. They give you the on each line you have 2 integers. Then later you have a sign that's slash, forward slash and backward slash. So then here the first integer they call the xi, that's x coordinate. Yi, that's y coordinate. Then that showed where the mirror they put on the field. Then the forward slash and the backward slash, that means different direction or different angle of that mirror. Then they ask you, this is the input, okay, output. Then they ask you output the 3 cases. One, if you did not adjust any mirror, then make the Farmer John can see the bar directly, then you output 0. If you whatever you adjust, but you still cannot make Farmer John see his bar, then you output -1. Otherwise, if you adjust the mirror, make the Farmer John can see the bar, then you output that index of that mirror. Then that's this problem asks you to do. Okay. See, now let's see if the original input, if you draw like this, can you see this picture, right? Can you see this?
Yes.
His Farmer John's house at coordinate 0, 0. This H means the location of his house. Then you have 1, 2, 3, 4, 5. 5 mirrors on this fence. The B means the location of the bar. Then say first mirror that's on the x coordinate, that's 3, y coordinate, that's 0.
Yeah.
Then this is a second one that x is 0, y is 2. Then this third one, it's x coordinate is 1, y is 2. Then number 4, mirror, x coordinate that's 3, y coordinate that's 2. The last one, it's x coordinate is 1, y coordinate is 3. Then say the farmer John just see to the positive of x direction. So he just see to this direction. Now let me use this one. He see to this direction. Then they ask you, is he first? You need to think, is he can see his bar? If he just see this way, bar definitely is there, right? If he see this way, definitely he cannot see the bar, right? Definitely that means he need see through this mirrors, right?
Yeah.
Through this mirrors, say this mirror will reflect the everything come from this part, right? Now let's see. From this part, maybe go here, right? Yeah, maybe there, maybe there. But this one, say, if go here, then what he sees is everything on this part, right? So now, say, they show you here, they show you even something there, but this one is very hard, right? Cannot help from John at all. Then let's see what are the errors what I draw. If Farmer John did not adjust the mirrors, he cannot see his bar, right? So then, can you tell me? Can you find which mirror he need to adjust to make him to see his bar?
The second one, the one right above the first mirror. If he turns it so
This
that
one.
yeah.
This one is number 4. Yes, you're right. See, the coordinate, if he make this one like this, right? Change the direction like this, then the mirror, say everything come from the bar will reflect to the mirror here, then he can see it, right? So that means he need to adjust this mirror. This mirror index is number 4. It's not 2. Because, yeah, let's go here. Then you can see this one is number 4. This one, say 1, 2, 3, 4. X equals 3, right? X equals 3, Y equals 2. So that means this one is index is number 4. Then the correct answer is 4. Output the 4. So that means if Farmer John adjust the mirror 4, then he can see his bar. Now this is our analysis, right? So now you need to think. See, if he do this, he adjust this mirror to this direction, then by this way, see, he can see his first he see this way, then by reflect here, anything reflect from here, then he can see his bar. Now to code, can you think how you can coding?
Yeah. So you know whenever the light hits a mirror,
Yeah.
if the light's going horizontal, it'll become vertical. And if the light's going vertical, it'll become horizontal, right?
Yeah.
So you're not gonna have a situation in which the light can go diagonally. So what you know is that in order for him to be able to see the barn, you have to have a mirror that's either directly to the left or right of the barn or directly above and below, like it has to be like perpendicular to the barn.
Right.
I think the way I would go about it is first I would obviously read through all of them and I would save all the mirrors as well as their orientation. And then I would limit so I would also have like a big matrix. And I would like set boundaries. So obviously if you're like light, I guess in this case, because if we treat Farmer John's like vision as like kind of like a like a projectile.
Right.
If the projectile ever goes outside of the range of mirrors or the domain of mirrors, then you know you've missed it. So I would set that range just so it doesn't like run for a million, because that would take a long time. And the way I would do it is I would probably just create a function to surf the current mirrors, because Farmer John will always go to the right, and then when it hits a mirror, depending on the orientation, it will either go up or down. And that's constant because you can just map out and see whether it will go up or down.
Right. Yes, I think you got the idea for this. Then for the coding part, do you use a function called new in Java? This one.
I don't know. I have
called
to see what NU does.
NUM.
Oh, I don't know what. That depends. What does I would have to see what the function does.
This one means you already know the output from your input. So there you already know the choices you have. Then you can use this function to define your choices. So in this problem, you need to use this function. Now let's go to the coding part. Let's see. Let's see. Okay. So recently, that's mirror. This one is a Java code. Okay. See.
Oh, so do they have the enum thing?
Yes. They use this one. Say by this way, they have 4 directions, right? And that represent north, east, south, west. Then you actually will have either n will change to the mirror will make the n change to east, and let's say here make the n go to east, then east go to north, then west go south go to west, then west go to south. This is one case. Another case, you can make the n go to west, and west go to north, then south go to east, and east go to south. So that means, say, suppose the mirror it's slash the forward slash like this, then if this mirror on the right side of Farmer John, then this one will make say east go to north, right? So if the suppose you can think this is the night or the vision, then if the Farmer John watch like this way, his vision the next sums come from east go to west, then this light will change direction to this. So then you can think anything reflect from the north to the mirror, then will change to the west to Farmer John's eyes, right? This is one way. Another way, if the mirror is backward slash, it's like this way. Then say the coming in, let me see.
It comes in from the north.
Right, then we'll change to the south.
Yeah.
Right? Go like this. Yeah. So that's the reason they use this enome function define these two cases. One case is like this part. Another case is like this part. Then later they can use this function to decide. Then the trace start from Farmer John's vision. Then trace one by one, trace each mirror, see if they have the mirror there. If they don't have the mirror, that's ray will bounce off to the ground or go to the sky. Then that means he cannot see his bar. Or if there's at that location has a mirror, but the direction is not right, he cannot reflect that ray to the direction of bar, then you need to think adjust that bar's angle, see if you can get that ray continue point to the bar's direction. So first you need to start from the Farmer John's location, then trace the first mirror, then from there based on this function see where this ray go. On that direction search if you have the next mirror there. If you have the next mirror, that's fine. Then start from that mirror, then continue. See if that ray can reflect to the direction of a bar. If did not reflect to the bar, then you need to check on that direction if you have another mirror, right? Until through the next mirror, the ray reflect to the bar, direction of bar. Then that means the Farmer John can see that his bar. If he cannot see his bar, then you need to adjust the mirror one by one. From the first mirror we are showed in that example, then go to the next one, then continue go to next one. Then when at that mirror, it's already next to the bar, but you cannot see the bar. That means you need to adjust the direction of that mirror. See if you can make the Farmer John see his bar. Okay, now let's read this code carefully. So the logic is just like that way. Start from the Farmer John's location from 0, 0, then check the ray direction, where the ray going, check, trace the mirror one by one. Then until go to a mirror you cannot see, but then it's still less to the bar, then you need to adjust that mirror. Now let's see this. See first, this the input, that function. Then now let's see, this is a public class they define called mirrors. Then this here they have map, tree map, and this one. Now they define a function called add. Add here has a coordinate x, y, and value. So here let's see, this one contains k v dot put x map h dot put y dot m map, then call this. Now let's see, print right. Then they also define, say, tree map. This one is this. Then another called done. Done, that means output this. Now define this unknown. This one help you decide the race direction. Where's race going?
Yeah.
Then
so that way when you can like kind of read, kind of like run trial and like see the way that it can go.
Right. Then they also define a blue, this one called OK. So now let's see, compare. In this one's compare you have two input, A and B. Then say if A, this one's not equals B, then return A minus B. A1, this one not equals B, return the difference. A2, return difference. Then integer x, y, set x, y equals 0, then get this d, e to d, d. Now check if this one's true, then see the return contains new x, y, then ordinal. Then if that one, then return false. Then C, if that's C, then add this one, then switch. Call that D, that's input. Then calculate this 4 cases. If n, then get a y equals this, break. If this e, then get the x equals this. Use this s, then calculate y. So yeah, this one just say use that function, help him calculate the, what's that ray come in, what is direction of that ray come in, then continue from there, separate these two 4 cases, then calculates what is the ray will go. Say if come from north, then they will calculate y coordinate. If come from the east, then calculate x coordinate. Source calculate y. Y is calculate x. Then later, now let's see. Here x equals 9 and y equals 9, they return false. So if x and y all don't have the value, then return false. The value give this one to value. If value equals 2, then return true. So if this value equals 2, then return true. So that means he can see his bar. If this one equals 0, then you give this d dot m0 to d. If this one equals 1, give the d dot m1 to d. So that means if this one, then it continue tracking. So that means it's still on the path, has a mirror. Then you continue tracking the next mirror. If you got a 2, that means he already see his bar. Then you get that's a result. Now this is that's all the function they define, sub-function defined. Here that's a main function. Main function they read in the input. Let's see. Input. Then now let's see here. Use this loop, then get this input. That's integer, another integer, and that's slash. Then add the x coordinate, y coordinate. Then if that's okay, then done. So that means if they read all of them, then done. Then they continue use this loop, calculate the x, y coordinate. If okay, then done. Then continue add this. So then later when if they get a 2, then that means they're succeed. They can see the bar. Otherwise, then continue check.
If so you like kind of go until you hit a mirror, and then once you hit a mirror, then you call it again, and then
right,
you go.
Right. But I feel this coding it's difficult, and also very long. Do you have any idea can make this code easier or part? Do you need have to use all this function like this?
I don't know. I think they use some weird like data structure, so it might be like they use some weird data structures, like they used a tree. So that I don't know if that was to help or if it was to like simulate the logic thing.
Okay, so I give you this one as your homework. You need to think, read this code carefully, understand that, and also then later, simplify this code. Rewrite your code, make your code more easier, but then you can still get this problem right. I think in this problem, they use a lot of more advanced coding skills and a lot of function, but maybe you don't need this.
Yeah, because I heard that didn't USACO used to be like harder back in the day or something like that. I don't exactly know the details, but I think people said it was like harder back in 2013, or if it was easier. I don't remember.
This one actually is 2013 January's problems. Okay, so this one it's your homework. This first problem. Now let's go to next one. So I already tested that code. It works. It's correct, but I feel that's hard. That's code. It's too hard. This one, it's C++ code, but then this one, the answer is not right. Now, can you read this problem?
Right. Farmer John has devised a brilliant method to paint the long fence next to his barn. He simply attaches a paintbrush to his favorite cow, Bessie, and then retires to drink a cold glass of water as Bessie walks back and forth across the fence, applying paint to any segment of the fence that she walks past. Bessie starts at position 0 on the fence and follows a sequence of n moves. Each example moves might be 10L, meaning Bessie moves 10 units to the left, or 15R, meaning Bessie moves 15 units to the right. Given a list of all Bessie moves, Farmer John would like to know what area of the fence gets painted with at least 2 coats of paint. Bessie will move at most 1,000 units away from the origin during her walk.
Okay, say.
Alright, so this one's easier.
Yeah, this one is much easier. Okay, see the input. It's this format. First, the line gives you an integer n. Then the start from the second line. You have say this input on the first line. This integer that's 6. So that means start from second line. You have 6 input, 6 lines of input. On each line, you have first input that's an integer. Then second one, it's either L or R. L means go to left side. R means go to the right side. Then the first integer means a unit, or the distance they go to that direction. The starting point is origin, it's 0. They start from 0. So now, say for this problem, if I draw a diagram is like this. Say the start from 0. Suppose here that's 0. Then say this first input is go to right side 2 units. So that start from 0, go to, suppose here, that's 2 units. Then go to left side 6 units. That means you continue start from here, not from 0. Okay, go to left side 6 units. So that means there will be go to here like -4, 6 units, right? Then go to right side 1 unit. So then we can use a different color. Now let's say we use green, and then by this way we can go here. Then now let's see from this -4 go to right side 1 units. So that means from here go to right side 1 units. So then here that will be -3. Then from here go to left side 8 units. So now let's suppose here, maybe I need to make this one longer. Go here. That's go from here. I need to change it, use other color. Then suppose I use blue. From here, oh, what happened? Undo. Yeah. Okay. Then I can use this one. I change this, yeah, green. From here, go to here. Suppose here that's this one will be -11, right?
Yeah.
Because from -3 go to left side 8 units. Then here will be -11. Now from here go to right side 1 unit. This will be negative 10. So then now let's change this one to another color. That's from here to here. Then from here go to right side 2 units. That will be, suppose it will be here. That will be negative 8. Then they ask you output the number of the areas the Bessie painted at least twice. Okay, see here, this first start from the origin, right? Then they go to right side 2 units, go to here. Then from here, then they go to left side 6. So this part, it's twice, because Bessie first go here, then go back to negative 4. So this part from 0 to 2, this part twice, paint twice. Okay, then start from negative 4, go to right side 1 unit. So this part twice, paint twice. Now from negative 3 go to negative 8. So negative 4 to negative 3 actually paint 3 times, right? Then from negative 11 to negative 10, then from negative 10 to negative 8. So this part paint twice. So then you can calculate the 3 segment get painted at least twice. That's negative 11 to negative 8. This is one part, one segment. Another is negative 4 to negative 3. Another is 0 to 2. Then you calculate length of each segment. This one is 3. This one is 1. This one is 2. Then you add these 3 lengths of these 3 segments together, interval together, you get a 6. So output, that's 6. So this is the problem we are our analysis. So then how to code it?
Yeah, I think so you code a number line from with like 1 million.
Right.
That's to represent the fence. Then you read in what direction and where it goes, and then so you know Bessie starts at 0, and you save her previous location, and then you save her new location after you take the move, and then you add 1, and then so in between all of those you would add 1 to like all of the you would add 1 to all of the things in between her like previous location and her new location, and then at the end of the day you could count which ones have 2 or more, and then you would know which ones have been covered twice.
Yes, I think your idea, that's correct. Just do like that way, then count which part of interval repeat twice, at least twice. Then memorize that the starting coordinate and end coordinate of that interval. Then do it one by one. Then each one, then get the length of each one. Then you keep add. Then later you output that sum. So now let's see what is this code looks like. Now let's see.
This one you don't have to do a matrix, like a one-dimensional array should be good enough.
Right, this one's a 1D. So this one called paint. So this one is a C++ code. C++ code, then this the input the libraries. Then this all the almost there every time that's the same. Then define a really big integer to cover all the numbers, largest number we need for this in this problem. Now here they use they call structure define event. This one help then they use say one integer called x, that's x coordinate, then increment, then this one the operate it's return this x coordinate from this event this event structure. Now this event they use after they define this structure, then they will use this this event, this structure, this before this main function. Then this is main function. They read in the input, they define the output, then define this integer n and k and x, then get this input. I think this one is almost so here they do the loop do say define a character c, then they get this c, so that's direction, right? The r and the l left. So say they just to this just choose L and R. If it's not that equals L or R, they just escape. Then they calculate the distance, x1, then start from the 0, then they calculate that distance. If they go to the right side, then they use positive 1. Add that to positive 1. If the left side is use negative 1, then they start from there 0, then keep calculate where is the location of that Bessie is. This x1 is the current location after that move. Then they calculate, give that input to that structure, then get that output from this structure, then compare x and x1, then picks the minimum one, then they call this one for, let's say, 2 times I, then 2 times I plus 1, and 2 times I plus 1 is one is coordinate, another is increment.
Yeah, because one of them, because you have like the coordinates, and then it will tell you whether or not to plus or minus
right
the number depending on
okay
what it is.
Yeah, then they sort. They do a sort the events and the events plus 2 times n. Sort, then now let's see. The n codes set initialize this one equals 0, then answer initialize as 0, then do the loop from n to 2 times n. So 2 times n, so for our this case n equals 6. So that means this one I will equal less than 12. Then compare if I is greater than 0 and number of codes. Oh yeah, because this problem they require number of codes at least equals 2. So that means you need to paint at least twice. So first they initialize this number of codes, this variable to 0. Then they calculate this n codes equals what. This at least say if this one greater or equals k, then they add then they calculate the nuts of that interval. Use this one and also add that number to answer, because answer will output the sum of the intervals, nuts of the intervals. So use if I is greater than 0 and number of codes is greater or equals k, then they calculate this. Calculate this nuts of the interval, then add that number to answer. Then here they update the number of codes. If this one, say, if they go one direction, path that means paint once, then they update this event dot inc, get one number. Then if they go back another time, then they add this one to a number of codes, add a number of codes at 1 to number of codes. Then later then check number of codes if greater or equals 2, then they will count that interval as the 1/9 of the interval they need for the answer. Then they calculate that nth of the interval, then add to the answer. Then later then they output this answer. Yeah, I think this problem is much easier than the first one.
Yeah.
Okay. Now this is a C++ code. Your homework, you need to modify this one to Java. Okay. Now let's go to third one. This the, but also say this code, the result it's not right.
Huh, that's weird. Maybe it's like a syntax error or something.
Yeah, when I combine, they said the x is not defined in the main function. Then I give the x, define x in the main function, then the output said the answer is different with answer. The answer is wrong. Okay, so this is the third one. Third one, the code works. Can you read this problem?
After spending so much time around his cows, Farmer John has started to understand their language. Moreover, he notices that among his N cows, some always tell the truth while others always lie. Farmer John carefully listens to M statements from his cows, each of the form XYT, meaning that cow X claims cow Y always tells the truth, or XYL, meaning that cow X claims cow Y always tells lies. Each statement involves a pair of different cows, and the same pair of cows may appear in multiple statements. Unfortunately, Farmer John believes he may have written down some entries in his list incorrectly, so there may not be a valid way to designate each cow as a truth teller or liar that is consistent with all of the M statements on Farmer John's list. To help Farmer John salvage as much of his list as possible, please compute the largest value of A, such that there exists a valid way to designate each cow as a truth teller or liar in a manner that is consistent with the first A entries in Farmer John's list.
Okay, so the input format is like this. First line, they give the two integers n and m. So first number means number of cows in this problem. So 4 cows. Then the second integer means number of information start from second line. So here that means the 3 statement here. Then start from second line to like 3 plus 1 to number 4. And for each line, it's of the form x, y, l. So that means this one, it's x said the y is line, l means line. Okay, or x, y, t, that means x said y tell the truth. So describe a statement made by call x about call y. So now let's see this example. We have 4 cows in this problem. Then have 3 statements. Say cow 1 said cow 4 lie. And cow 2 said cow 3 tell the truth. And cow 4 said cow 1 lie, tell the truth. So now let's see. Here they ask, this is the input, right? So say we have 4 cows and 3 statements. Cow 1 says that cow 4 lies. Cow 2 says that cow 3 tells the truth. And cow 4 says that cow 1 tells the truth. So then the output asks you, the format only give you a output an integer, but this integer, it's a maximum value of a such that the first a entries in Farmer John's list can be consistent with some consistent of true Taylor or line to the n cows. So that means they ask you this 3 statement. Actually, they ask you output the how many statement will true. Okay, see the way to do this. Then they said you can separate the statement as 2 groups. You know, the by this way you separate the cows as 2 groups. Then the one group, they are in the same group. That means if the cow, like say cow 2 said cow 3 tells the truth, so that means cow 2 and cow 3 in the one same group. Suppose that's one, it's A. So that means 2 and cow 2 and cow 3 in the same group. Then say for cow 1 tell the cow 4 is lie. So if they said this one equals line, so that means the cow 1 and cow 4 in the different group.
Yeah.
Okay.
So this makes sense. So
yeah.
In this case, you would just make a array with the number of cows, right, in each spot, right? It represents 1 cow, and you know cow 1 will always be correct.
Right.
You can just go ahead and assign the first thing as a t, and then so you in this case, right, 1 says 4 is an L, so you assign cow 4 the L.
Right.
And then in this case, 2 says 3 is T, so you can assign the T, right?
Right.
And 3 doesn't say anything, so you skip over 3. But in this case, 4 says 1 is a truth teller. But we already have from before, we've established that 4 is a liar, which means you have to flip whatever 4 says. So in this case, because we've already saved an L and 4, we just do like if, I guess the index of 4, which would be 3 in this case, equals L.
Right.
And then you read it. If it's a T, it becomes an L. If it's an L, it becomes a T. And in this case, it's a T, so it becomes an L. But that contradicts with something we already have. So that means that the only first 2 statements are correct.
Yes, exactly. Yes. So you get that. So the analysis just like this. See, they said second statement. This statement definitely you cannot tell that wrong. But then say the first statement and the third statement only can one be true, another definitely will be wrong. These two statements definitely cannot both right, both true, right? Only one true, one's false, right? See, call one said call four lie, right? And call four said call one tell the truth. So how these two statements can only has one is correct. You cannot say that call one said call four lie. You said this one's true. And also you said call four said call one tell the truth. This one also true. This definitely is impossible. This one, because this said that if you separate, if this one's T, that means this one in the same group. Then this one, the L, that means a different group. So that means in the different statement, in the different group, that means can only one is correct. Another one definitely will be the fourth. So the second statement, we cannot tell that's false. Definitely we can suppose that's true. So then in these three statements, maximum true or maximum the group that should be two, right? You can only have maximum two are true. So then they ask output the number of the truth in these three statements. That's the answer is two. Okay. So now let's see.
So you would just keep going until you find a contradiction, and then you would break out of the loop.
Right. Say the output detail. Statement 1 and 3 cannot both be satisfied at the same time, right? Say first statement and third statement cannot be satisfied at the same time. Only can one satisfy. But the statements 1 and 2 can be. 1 and 2 can sacrifice at the same time. If we let cows 1 and 3 tell the truth, then cow 4 be a liar. Then we will have two statements are true, right? So then we'll output correct answer, that will be 2. So then now let's go to the code. This one's choose. This one they give you the two algorithm, but the code are all C++. Say this one, it's first C++ code. This one is longer, but then this one said like brute force way. Then the second one use more advanced algorithm. Then the code is shorter. See this one, it's kind of easy. Just they don't use any other advanced features. Then after they define include the library, then they just go to the main function, define the main function. The input choose dot input, choose dot output, then read in the input, then they do the loop call this later line L or T, right? Get this one, then they calculate that to compare that if they're true or false. If the truth, then they put there in the same group. If it's L, then they put to the different group. Then they calculate, say after here, then say if that's equals T, then they put to the component. If not equals T, go to the negative component. Then components A, another define that's component B. Then do this loop to calculate how many in the how many members in the components A and how many in the components B. Then let's see, then output the M. So it looks like they just based on the L and T separate the cows to the different group as group A and group B. Then they calculate number of cows in each group, right? Then they pick the largest in the group A and group B. Then group A, if I have these two group, which one has a larger number? Then they output that number. Yeah. So this one.
Not.
Yeah. This one's not.
The first one was the hardest.
Yeah, that one's the hardest. So then your homework. Simplify the first one, then modify the last two to Java. Okay.
Okay.
So then time is up. We can stop here. Bye.